right, for 49 and 50, we are converting from rectangular to polar. And so we have the ordered pair -1, 1. That's rectangular. We want to switch it to r theta. So to find our r value, if you look at your formula sheet, converting from rectangular to polar, x squared plus y squared is equal to r squared. So we're going to put in our x value of -1 and our y value of +1. Now please notice that negative does get squared as part of our x value. So -1 squared is 1, and then 1 plus 1 is going to give us 2 as r squared. So to get r by itself, take the square root of both sides, and we'll get plus or minus the square root of 2. Now, if you'll notice, your problem told you to give the positive r value. So we're going to give the positive square root of 2, because if we did the negative square root of 2, when you change the radius to a negative, you have to add pi to the theta, and we're just going to keep it simple and stick with the positive one. All right, so then we want to find our theta value. So again, if you're looking at converting from rectangular to polar, it says that to find theta, you're going to do tan theta is equal to y over x. So our y value was 1 and our x value was -1. That means tangent is equal to -1. So we're going to look on our unit circle and we're going to see where tangent equals -1, but that happens in two different places. So the way that I know which of those values I want is come back over here to your original problem. Where is -1, 1? It's in the fourth quadrant. So I need to give the tangent value that's equal to -1 in the fourth quadrant. That would be the 7 pi over 4 off of your unit circle. All right, then 51, it asks us if r is equal to 2 minus cosine 4 theta, what would your r value be when theta is pi? So let's put pi in for theta. And you can throw this whole thing in your calculator. If you do, though, be sure that you are in radian mode, because that's a radian value, right? Or you could work this out by finding the cosine of 4 pi is 1, and then 2 minus 1 is just 1. All right, for 52, we move into our conic sections. All right, so for 52, it says, find the equation of a parabola with a vertex of -2, 1 and a directrix of x is equal to -5. You do not have to make a graph of this. I just make a really rough sketch to help me envision which direction that this is going. All right, so if I have a vertex at -2, 1, that actually should be up a little bit, about right there, -2, 1, and a directrix at x is equal to -5, remember that your parabola has got to open away from the directrix. It doesn't cross it. So that lets me know that I'm going to be opening to the right. So if I'm opening right, then that is a horizontal axis. So again, if you go look at your formula sheet, you could pull this equation off for when it opens left and right, or when you have a horizontal axis of symmetry. All right, so now let's put in our vertex. So your vertex is hk, so h was -2, k was +1, so h is -2, so x minus a -2 would be x plus 2, and then k was +1. Remember, again, it's like the opposite of each of these values because of that negative there. And now all we need to do is just find our p value to fill in here and we'll be finished. So p is the distance from the vertex to the directrix, or from the vertex to the focus. I don't know anything about the focus, but I do know the distance from the vertex to the directrix was 3. So p is 3. And to know if it's positive or negative, if it opens right, it's positive. If it opens left, it's negative. So ours is going to be a +3. So 4 times 3 is going to give us 12 for this value. And so now we've got our entire equation. All right, for 53, they give us the equation y squared plus 8y minus 12x plus 4 is equal to 0, and they ask us to find the vertex and the directrix. So the first thing I need to do is I need to get this in standard form, and to do that, I'm going to need to complete the square. So I have a y squared term. That means that to complete the square, I'm going to be doing that with y. So let's get all of our y's on one side and everything else on the other side. So to complete the square, we take the coefficient of the middle term, that 8, we cut it in half, and then we square it. So 8 divided by 2 would be 4, and 4 squared would be 16. So I'm going to add 16 here, and what I do to one side, I have to do to the other side. It's called completing the square because what I made right here should be a perfect square, meaning when I factor it, I got y plus 4 times y plus 4. That's y plus 4 squared. We made a perfect square. So over here on the other side, the negative 4 and 16 is going to be positive 12, and then we can just take out the greatest common factor over here, which is 12. So now I've got this in a form that I can look at it and I can see my HK. So HK is my vertex. So again, what's being subtracted from X is a negative 1, or think of it as the opposite of this number. And then over here, what's being subtracted from Y is a negative 4, or think of it as the opposite of that number. So my vertex is negative 1, negative 4. All right, then they also asked me to find my directrix. So when I'm looking at my equation, you can see it's X is equal to Y squared. So that means that it's going to open left and right and have a horizontal axis of symmetry. And because this 4p is in the place of 12, if I set 4p equal to 12 and solve, I get p is equal to a positive 3. So if it's a positive 3, that means that it's going to open to the right. So p is 3, so that just means that if I'm opening to the right, then my directrix is going to be behind it. And so if my vertex was at negative 1, negative 4, if I back up that p-value of 1, 2, 3, that's going to put me at x equals negative 4. So my directrix then would be x equals negative 4. For 55 and 56, they give me the equation of an ellipse. So remember, when it's x squared, y squared, and it's a plus, it's an ellipse. If it's a minus, it's a hyperbola. So for an ellipse, remember that your major axis is going to be your larger one. So since 36 is bigger than 25, then my major axis is going to be vertical, and that means that A is going to go with Y and B is going to go with X. So look on your formula sheet. Here is your major axis vertical equation. All right, so first off, we need our center. Nothing's being subtracted from X and Y, so that means that our center is 0, 0. And if we match this up, we can see a squared is 36, so a would be 6, and b squared is 25, so b would be 5. So we can come over here and say if we started our center at 0, 0, and our major axis is vertical, we're going to go up 6 and we're going to go down 6 to get to the endpoint of our major axis, and those endpoints are my vertices. So I would have a vertex at 0, 6 and at 0, negative 6. If they had asked me for the covertices, then those are the endpoints of the minor axis, so that would have been negative 5 and positive 5. If they had asked me for my foci, then I could have used my equation a squared minus b squared equals c squared to get my c value. That's the distance from the center to the focus, and I could have gone from the center to the focus and from the center to the focus. So it would have just been 0, my c value, and 0, my negative c value. We'll see one of those in just a second. So then for 57, they give us another equation of an ellipse. And again, remember that with an ellipse, the major axis is your larger one. So since 25 is bigger than 9, my major axis again is going to be vertical. So let's go to our formula sheet and copy that equation for major axis vertical. So if we match that up, our center is HK. So you can see what's being subtracted from X is 3 and what's being subtracted from Y is a negative 2. So again, like the opposite of each of those numbers. So 3, negative 2 is going to be my vertex. And then, my center, sorry, not my vertex. And then you can see a squared is matched up with 25, so a would be 5. B squared is matched up with 9, so b would be 3. So let's start over here at our center, 3, negative 2. The major axis is vertical, so we're going to go up and down to get to the endpoints of our major axis. A is the distance from my center to the endpoint of my major axis. So from right here, I'm going to go up 1, 2, 3, 4, 5, and that puts me at my vertex. And again, from right here, go down 1, 2, 3, 4, 5, and that puts me at my other vertex. So you also could use logic to figure that out and just say, okay, if I take negative 2 and I add 5 to it, that's 3. And if I take negative 2 and subtract 5 from it, that's negative 7. So there are my vertices. To find my covertices, again, I'm going to start at that center and I'm going to go my B value. So I'm going to go 3 this way and 3 this way, and that would put me at my covertices. What they asked for, though, were my foci. Now, my foci are always going to be on the major axis. So I start at my center and I go up my C value and down my C value to get to my focus. So I need to find what C is. So the equation relating A, B, and C for an ellipse is A squared minus B squared equals C squared. So I just plugged in what we knew for A and B, and we're able to solve to find out that C is equal to 4. So if I start right here and I go up 4, that puts me at one focus, and go down 4, it puts me at the other one. So here are my foci. You also could just say -2 plus 4 is 2, and -2 minus 4 is -6, and get to them that way as well if you wanted to. All right, then for 59, they're going the opposite way. They're giving me the information, and I'm coming up with the equation, which we found to be a lot easier. So for 59, I have foci at -2, 0 and +2, 0, and the length of my major axis is 8. Okay, so again, I don't have to graph this, but it just kind of helps me envision what I'm working with. So I have a focus at -2, 0 and at +2, 0. That automatically tells me my major axis is horizontal because my foci are always on my major axis. It also tells me my center because my center has to be halfway between those two foci, so that means my center is going to be at 0, 0. And it tells me my C value because the distance from the center to the focus is my C value, and that distance is 2. So I got all that from those two foci. The second thing they tell me is that the major axis is equal to 8. So on our formula sheet, the length of the major axis is 2a. So if 2a is equal to 8, then a is equal to 4. And once I know a and c, then I can use that equation to help me find b. So a squared minus b squared is equal to c squared. Let's solve that for b. So I just added the b squared to the other side and subtracted the c squared over, so it was already solved for b. So plug in what we know for a and c, and we're able to figure out that b squared is equal to 12, or b is equal to the square root of 12. Since the major axis is horizontal on your formula sheet, let's go grab that major axis horizontal equation. There it is right there. We need to plug in HK. Our center was 0, 0, so we're just going to put in 0 for each of those. And then we said A was 4, so we'll put in 4 right there. And we said B was the square root of 12, so we'll put in square root of 12 for B right there. And so if we clean that up a little bit, we'll have x squared over 4 squared, or 16, and y squared over the square root of 12 squared, or 12, and it's always equal to 1 in standard form. Same idea for number 60, only for 60 this time they tell us that it is a hyperbola. And so they told me I have foci at -4, 0 and +4, 0, and the length of my major axis is equal to 4. So again, I come over here to -4, 0 and +4, 0. That means my major axis is horizontal. My center is halfway between those 2 points, so it's at 0, 0. And the distance from the center to the focus is my C value, so C is 4. Length of the major axis, 2a, was equal to 4, so that means a equals 2. And once I know a and c, I can find b. Now be careful, because with the hyperbola, the equation for a, b, and c is different. It's the Pythagorean theorem, a squared plus b squared. Up here it was minus, right? So a squared plus b squared is equal to c squared. And again, I solved that for b. I just subtracted a squared from both sides. All right, so c was 4, a was 2, so we plugged those in. And we got b squared is equal to 12, or b is equal to the square root of 12. So if we come over here, our center is HK, so let's plug in 0 for H and K. And then we found A to be 2, and we found B to be the square root of 12. So let's put in 2 for A, so 2 squared is 4, and square root of 12 squared is 12. And there is the equation of our hyperbola. All right, for 61 through 63, they give us this equation, and they ask us to find the center, the foci, and the vertices. All right, so first off, if I line this up with the equation from up above, I can see that my major axis is going to be horizontal, because with the hyperbola, the major axis is always the positive one. And so x is positive, y is negative. So you can see h is going to be 3, k is going to be -2. So there's my center. And you can see a is going to be 3, and b is going to be 5. Then once I know A and B, I can use Pythagorean theorem to find my C value to be square root of 34. So they asked me to find my vertices. So we said major axis was horizontal. So I'll start right here at my center and I'll go over my A value of 3 and go back my A value of 3. So that gave me my two vertices. And then the foci are on the major axis. So if I go forward my C value and backward my C value, then that gives me my two foci.